So, what's happening now? Okay. I'm from Greece, but living in Germany. I'm working for a German-based company. It's called Enruns, and I'm doing the penetration testing, also source code reviews, and also giving developer trainings. And prior joining Enruns, I was a software developer for 7 years. So that's about me. Before we start, I assume that you're confident with cross-site scripting, what it is, the impact, etc., and what you can do. And furthermore, I expect what a filter should do in the best case. The talk is not about how to write a secure filter, and also I will not present you new groundbreaking cross-site scripting bypasses. So if you think you want to leave, maybe you have a coffee or a nice cake or visit another track, just to be fair. Okay, so the talk is more about to understand what kind of filter mechanism exists, and furthermore, you consider this talk more as an overview for you as penetration tester, for you as a software tester, for you as a software architect who have to design a secure application, but also for vendors who are giving or having appliances to protect against cross-site scripting and other vulnerabilities. So this is more like keeping track of information. Acknowledgement is very important. First of all, S makes great cross-site scripting cheat sheet. And also, everybody who posted at the slackers.org forum, there are many great ideas there, and many bypasses were discussed at this forum at the first place. So if you want to be or stay tuned on everything, I recommend to visit the site regularly. Okay, so first of all, this is my agenda, and the introduction is quite easy. Why we need cross-site scripting filters? Because of the social networking thing, or I'm calling it express yourself methodology. So everybody wants to express himself with nice pictures, with a lot of other interesting videos or other media files, and at the end, if you start a company, you want to be successful in the Web 2.0 century, and you need a lot of visitors to make money. So you must offer your visitors this functionality to express themselves. So this means at the end that you have a problem in a security way. So the problem is quite easy if you're thinking about security and what you should do in the best case. This is, first of all, a very strict input and output validation. Input validation means priority. We have a whitelist, which is very strict. And also, if you're doing output validation, it means you encode your data properly. But again, if you do it like that, no visitors, no money, no business. So the reality is completely different. So we have the theory and we have the practice, right? And we know there are two pairs of shoes. So the reality is that the whitelist approach does not match at all, because the user data is not predictable in any case. And if you allow the users to put flash files, an example that the previous talk was about flash parameter injection was very good, by the way. And if you follow this track, then you know that how easy it is also to break a very good cross-site scripting filter through a vulnerable flash file. So on the other side, encoding output does not work at all, because the data of the user must be renderable. So if I want a pink background color, so I should allow this, and also if I want that a user want to embed other images, this is something that I also have to allow. So the mitigation, the software architect. So it comes up because there's some functional specification from the manager, and then comes up to the software architect and tells them, okay, this is what we need, what you can do right now. So, and the software architect will say, okay, dear manager, there's no problem, we are using a framework, and this framework has for us a lot of security features built in, like an example, the .NET framework. So we are having kind of request validation security mechanism, which should prevent us against cross-site scripting. And the reason is because some special characters are not allowed there. So the left angle bracket and the right angle bracket in this case. So, and whenever the framework sees these characters, then immediately an HTTP request validation exception occurs. So we are safe against cross-site scripting, and you know what? We are using also ASP.NET web controls, and they automatically encode output by definition. And and furthermore, we're using also white loss approach because we know this is very good at all. So this is a software architect. Now we are coming to the developer view. What happens? Yeah, we suffer from depression, right? So we are starting now to convince the software architect this is also a completely bad idea. The general security features of the framework does not work. The whitelisting does not work at all, because if we should allow user-generated content in our website, so we need to allow the left and the right bracket, right? So this does not work at all. So in the next point, what you should do, or mostly the developers are doing, they're starting to count which security vulnerabilities the framework had in the past. So if we are thinking about the .NET framework, there was some really nice exploits around. There was a bypass if you have a verification site there, and also there exists very good white paper from a UK-based company which tells you how to bypass this mechanism completely. So what happens next? We should find a compromise. So, and the compromise is usually to define a blacklist, because this does not affect in any way the functionality of an application if you built it already. So, how we should filter now? There are some 3 approaches right now that I saw it in different kind of source code by customers, but also from some open source projects. At the end, I will give you another advice how you do it better. So the first approach is the string and deny input approach. So I'm calling it like that. So this means if the data contains bad character or bad word, we should not process the user input further. And what happens? We just send an error message. Or if we are relying on the .NET framework, we get an HTTP request validation exception. This is something that I do not see quite often. I guess this is not very user-friendly, and I also saw some web application firewalls that were just only in passive mode, but this is just a joke. The next point is the substitution and continue approach. So if the data contains any predefined bad input, what we should do, we usually strip it out or replace the data with other harmless data. And afterwards, we proceed with the new validated user input further. This is something that usually happened, maybe because it's very user-friendly and because we don't have to care about any error messages. And for the developer side of view, it's also very simple to handle it. So the next approach is done by regular expressions, and I'm calling the seek and destroy approach. What we are using is the same basic approach as before in combination. And this is usually the de facto standard solution. So, and we're using here the regular expressions as the Swiss Army knife for everything, for every input validation in general. So, if you're aware of the Owasp anti-semi project, anti-XSS-Semi project, then you will see that there are a lot of cross-site scripting prevention mechanism implemented through regular expressions, and also the brand new beta 2 from Internet Explorer version 8 has also implemented a lot of regular expressions, which hopefully suffer you from XSS. Something?
Yeah, I just need to charge it because we have another presentation. Sorry.
Just take it. I think this is mine, yeah. Okay. Never mind. So what's the pitfalls about these approaches? So first of all, we have to define the bait data, right? And now we're discussing the pros and the cons of each approach. So the string search and deny input approach is first of all very easy to implement. Yeah, and deny is always good to have it. On the other side, we have to define what kind of data is bad, and this is usually based on the user experience. And on the other side, we know also the bad list is by definition not complete. And also usually if I'm doing it via string search, these kind of characters or words are case sensitive, which is also not so very good. And we also have to think about canonicalization in this point if we're dealing with characters from Asia or other countries or continents. So on the distribution and continue approach is first of all quite easy also to implement, but is already very user-friendly for the data flow, for the application. And we have again the same disadvantages that we have to define the bait data, and yeah, in the next point we should or we could also substitute harmless data in any point, which maybe affect your logic business, the logic business of the application, and we also know in general that data correction is prone to security issues as well. So just be aware of it. And also there are some other needs, kinds of possibilities, which I'm discussing later, how browsers are handling different kind of specific characters, not like null bytes, etc. So on the next point, we have regular expressions. In general, the pro side we have the same one, and on the contra side we have the same problems as before, but we should know that to write a regular expression could be a really great challenge, depending on what you have to do, and also regular expressions leads to logical flaws. So my question is, do you know the match only at end of string modifier, which is part of the zero wizard section? Somebody is here who knows this? Okay. Okay, so just an example. This is Perl, and this is our whitelist. We are searching from the beginning of the string to the end of the string that we are allowing just only lowercase alpha characters. So, but what we are giving here is also at the end a new line character. So my question is, what do you think is the result now? Is it true or false? Okay, who is for true? Raise the hand. Who's for false? Okay, cool. It's true. So why it's true? Because of it's matched not really at the end of the string. Yeah? So if you want to do it like that, you have to use another modifier. On Perl, it's set, the small set. On PHP, I think it's the uppercase D. And only this modifier looks really at the end of the string. So, and this quite neat example demonstrates you how sometimes you can bypass also a logical, very good cross-site scripting filter. It depends now after what's happened with the data. Yeah, but this kind of regular expression could lead to other vulnerabilities, SMTP injection or HTTP response splitting and so on. So what kind of evasion exists? So for my experience, I just put it into 3 categories, or to 2, and I split it again. So first one are technical based, and the next one are human based. The technical one, I just split it up into logical flaws and third-party issues. So what is it exactly? So the logic flaws, I put everything that I mentioned before on the disadvantage side from the filters, from the basic approaches there. So we can miss a bad character or words. This is something that can happen. We can also use a wrong regular expression, or use or forget about one modifier. We can also do another fault. We elect the wrong regular expression library, and I will demonstrate it later on the example section. But there are also some other typical logical flaws. What happened if you are tired as a developer, that you are mixing up the compare statements, the 2 equal signs, with just 1 equal sign, which reassigns the value, right? And also the same issue applies if you're doing logical or, unfortunately, bit operation on that. The next point are false assumptions of the safe API, because you're not reading the documentation and you just only expect what the method names is giving to you. And next one is endless loop condition due parsing bugs. This also happened quite often, and I recommend you to fuss maybe the M player. Then you always get very cool call stack overflows on this neat application, because there's some really nice parsing bugs into this great media player. Third-party issues. This is very, very interesting. This is kind of a second-order bypasses, because you usually can't do anything. So we have the web server side, we have the browsers, we have the browser plugins, we have also the operating system, which can help us to bypass the cross-site scripting filter, and also we can use the API, an example for Facebook or for MySpace or for eBay, and we are able then to trigger cross-site scripting. So from the technical side, third-party issues are very interesting, and in general, if you're seeking for web servers, you should also look for error pages. Why you should look like that? Because usually you forget about the infrastructure if you think about the application. So you forget about to exclude examples there, but also to forget about the hardening guidelines if you have someone. So whatever module you are using, this maybe is prone to cross-site scripting. And for this case, be aware of it. Just be always up to date. And the error pages, the last one from Apache, affects the 413, the request entity to large parse error. And it's not so old. Then we have the browser, which is very, very interesting because it's a really black box. So there are some issues that Internet Explorer had, Opera and Firefox, I don't know if you're aware of the multiple web browser UTF cross-domain character set inheritance. This was discovered by Stefan Esser, and he found out that if you're putting some child frames, the Internet Explorer 7 and afterwards also Opera and Firefox, they inherit the default chart for the parent window, and even if the character is specified in the content type header on the meta tag, then you was able to pass UTF-7 string, and for this case, then you was able to do kind of cross-site scripting. The next point, the big issue on that is the parsing of HTML and JavaScript, and also caucasization issues. So we have, for the Firefox, last year, the invalid trailing character in HTML tag attributes. So we had kind of often a on-load invent, and you put some characters afterwards, and this browser or the JavaScript engine of Firefox did not care about it and just execute the statement afterwards. We have also some strange behavior if we dealing with ASCII characters, if we not are in the range of a 7-bit. And we have also null bytes which help us. So the null byte, and especially in Internet Explorer, is completed ignored. So also antivirus industry is now aware of it. So what you can do is to put also kind of virus inside and put also null bytes in between, of an example for file names. And if you're just looking for file names in your blacklist, then you are able also to bypass it. So, and it's going on. Especially if you're dealing with different kind of character sets. We have kind of variable width encoding, white spaces, and line feed characters that are also interesting, which somebody using Firefox here, maybe maybe you see or you saw that Firefox released today a new version. And why they released is two issues on that, because their handling of white space characters, if we are dealing with Unicode. I will show you later on. And then we have also the best fit mapping mechanism inside from Unicode. I will show you also an example, and swallowing as well. So an unusual JavaScript, invalid HTML, and fragmentations, also MIME type handling is also an issue on that, and also other input which comes in, like RSS feeds, but also new HTML extensions. Just think about Firefox, but also think about the E4X extension, which is quite new, or with HTML5 canvas, so you are able to render images and so on. Just keep this on track. So on browser plugins, we have Flash and also Silverlight, and as mentioned before on the track, it's quite easy if you found a vulnerable Flash file to bypass the cross-site scripting. And it was, I think, 2 months ago, also on full disclosure, an advisory from Una Pinonen that also shows how to do that with Facebook, and also with Facebook API. Then we had some, in the past, also the Adobe Univol cross-site scripting vulnerability from Stefano Di Paola, and also other browser plugins like Firebug or Sarge RSS Reader. And we should also keep in mind that we are able also to backdoor media files from movie to MP3. And I think today on the blog of, I guess it was Watchfire or now IBM Rational, the guys that were prior to this talk, they also find out that Winamp, for an example, if you're putting ID3 tags into it and you put just JavaScript code into it, it will be rendered and will be executed. Also PDF. Usually Adobe comes up with enabled JavaScript, so be careful if you open a file which is called in the end .pdf. You are able, in the beginning, before the first page is shown, that this JavaScript can be executed, and there was in the past also some exploits in the wild. Just keep that also in mind. And also images, and I will show you some examples on that. Yeah, we have also the operating system. And the operating system have also to deal with different kind of MIME types, and this could be also an issue. And also the URI one, especially the data URI regime. You should keep also that in mind. Yeah, and we have APIs that we may expose to the public. Just to be also successful in the business, we have to collaborate, like Facebook is doing it. And so again, there was an issue with this method here, and he was able to inject cross-site scripting into Facebook through this API. And also upload services could be an issue as well, especially if you upload malicious files onto it. Antivirus solutions are not protecting you against this. Okay, and the next one, we have the human side. And we are all humans, we are all making faults, unfortunately. So how we handling the data which comes up from the web server side or from the browser side? I'm just thinking about double URL decoding as an issue. And this is also very nice on that. If you think that your cross-site scripting filter passes Elsnake's cheat sheet, it does not really mean that you are safe from cross-site scripting. I will show you later on an example on that. And again, API misinterpretation is something that I also often seen. If we have a method like strip tags, it should strip tags, right? But there are some issues on this method, especially in PHP in this one. And you always trust third-party services or internal data services as well. This could be also an issue on that. And in summary, all issues that I'm just read, just presenting, they're also usually root of logic flaws. So we're coming up now with some examples. Technical ones, some logical things. So who knows Horde framework or maybe Horde webmail? This is very popular webmail, especially in Europe and in a university. So they just forgot about the frame and frame set in their cross-site scripting folder. Even better, an appliance, Firepass engine. So evil functions are rewritten by the Firepower engine. So they did what I mentioned before. They just rewrite the malicious data. But double evil functions are ignored. So why happened this? Usually because of this regular expression. We're having here the script that is malicious, but what about this script here in the front and the back? So what happens is, if we evaluate this statement, we will get script again. And the only thing what we should do is to have kind of a while statement here. Then we really strip the script statement. So another interesting thing is regular expression libraries. So especially if you're dealing with PHP, there are the POSIX expression library out there, and this functions, or the complete array function family, is not binary safe. This means that the null byte ends the strings up. So whatever afterwards come in, it will be not evaluated by these functions. And again, the Perl-compatible regular expression was usually often used. Had in the past very serious vulnerabilities. So update your distribution or your appliance or whatever as regular as often, because then you have some other issues as well, unfortunately. So we have browsers, and who knows the Notepad bug here? This app can break. Somebody? Okay, somebody using Windows XP. Okay, then open Notepad and write this app can break. Yeah. Save the file. In my case, I pronounce it test.txt. Close Notepad and reopen it. What happens? This one. What happens? Yeah. Well, first of all, Notepad has to edit files in variety of encoding. Keep that in mind. So, in the first place, what happens is internally they're calling a function, and they want to find out if this text inside what is stored there is Unicode or not. And and sometimes then Notepad is forced to guess what kind of character set the input is. And for this reason, we are getting the strange characters there. And if I have installed some Japanese characters on this machine, then somebody who's from Japan maybe could read what happens afterwards, after this parsing issue. So why should a browser behave completely different like Notepad here? So the browsers also acting like Notepad, they are also must able to render different kind of character sets, right? So the problem is that they have to guess what kind of character it is. So what they're using is kind of best fit mapping. An example, the ASCII. Use ASCII 7-bit, but what we are giving here is some really strange characters on that. If we force the browser to represent us this as ASCII, we also get an alert box here, cross-site scripting. Yeah. So what is or why happened this? This is the statement, right? You see, this is definitely not the one that you should expect or expected in the case. So the browser should guess now what an example the %A2 is. And what it is doing is, first of all, maybe it's cast it down to a decimal representation. And then he knows, okay, the ASCII character set is a 7-bit character. So, okay, maybe I should do a subtraction on that. And then I'm got 34 as a decimal value, and the hexadecimal representation is 22, which is also a quote. So the browser is telling us then, or is interpreting this input as a quote and as a left angle bracket and as a right angle bracket, unfortunately. And this also happens with the Japanese language character set. It's called ISO 2022. It's also a 7-bit character, so this works as well. And what you can do on this is an example what happens on 2002. You can spoofing URIs. And this is one reason why also Firefox patched, I guess, their patched a vulnerability against it, and was released today. White space and line feed characters. So if you're reading the specification in HTML4, then you find out on the section about white space characters that the browser should deal with these kind of characters. Space, tab, form feed, things that you should usually don't know, 0 width space, and also line feed and carriage return that somebody knows. So what you can do on that is maybe to serve to file format.info, and then you can put in a character, and this very cool website is then giving you another pieces of valid characters that are listed and categorized in the Unicode consortium. So as you can see, then we have in complete 19 white space characters there. 19, not only one. So what we can do this is then to pass it to our cross-site scripting filter and to see what happens, or better to the browser, if the browser is treated these characters as a white space. And this is, it was done, or did also Chris Weber, and I think it was 1 or 2 weeks before he posted his result of full disclosure. And the subject was attack of the Mongolian space invaders and other medieval cross-site scripting vectors. And he just found out that these kind of white space characters passes the Opera engine, and the Opera just treated as a normal character and usually shallowed it, and as a result, cross-site scripting was possible. And we have some other possibilities on that. I like this nice character here. We have also the 0 with no break space as well. And this byte order mark was also an issue in Firefox, and with a new version, it was fixed right now. But the most interesting part of it is that on 2006, this issue was also discovered by a Japanese guy. I forgot his name, sorry about that. And then they fixed it on the branch, on the 1.5.0.4, I guess. And it was introduced now with the new Firefox version 3. I don't know why. So third party, we talked about white spaces and line feeds, but now also well-known character is treated as white space on the browser engine. I have here an example of that. This was I think 2 weeks or 3 weeks. 3 weeks was released in cooperation with the OSA team. We published this advisory. So the forward slash here is treated by Firefox and Internet Explorer as a white space. So what you can do is, just to put your, or you can bypass the filter, because the Horde framework uses a cross-site scripting filter on that, and for this reason, it was possible to execute JavaScript. And this is really, really bad, because if somebody sends you an example, a file which contains HTML or whatever, you open it, then you're controlling the complete application, can send emails and so on. And there was another issue on that. They just forgot to encode the file names of the MIME type attachments as well. So even better if you just click one message, then you get owned quite easy. So the next point is HTML parsing bugs. If you have this input here, which is definitely well-informed, what do you think what should the browser not do? It should not append the missing script tag here. But unfortunately, Firefox did it in the past. So this is also very interesting, because you can just send broken HTML on the site, and the browser is interpreting it as a valid one. Just keep this also in mind. Yeah. Another one is parsing of files. So if we are preparing a file like this here, there's a shell, I'm putting some magic bytes on that. This is a valid PNG magic bytes there, and afterwards I'm putting HTML. We should not expect that the browser is executing it. But unfortunately, this happens. So why it happens is very, very interesting, because it's depending on the operating system side. This happened also on Firefox, by the case. But this is a very EA and Windows specific. There's a function which is called find MIME from data, which reads the first 256 bytes, and then they trying to guess the MIME type. And there's 26 hard-coded tests inside, and if they found, for an example, the HTML tag there, they treated it like a valid HTML file. So that means they give you, as a result, the text HTML MIME as a result back. And this is very bad in this case, because you are able to force somebody just only to click for a file which contains only a media file. And usually everybody thinks that a media file does not contain, what's this? Hello? It does not contain any malicious input on that. So for conclusion, I don't know what's happening. Sorry about that. As conclusion, security is like history, so keep this in mind. So all vulnerabilities are striking back just with new fashion clothes. Also, the IPS IDS evasion techniques was one discussed in 2002, 2003. Also applied to the browser world as well. There are 2 very good papers on that. One was released on DEF CON, another one on Black Hat 2006. Just have an eye on that. So sorry, I don't know what's happening here. And furthermore, just for cross-site scripting filter writers, what you should always do in the first case is you should canonicalize the user input with tidy or with DOM. And afterwards, you should proceed with the data further. And just keep in mind that browsers and extensions are completely black box. You don't know what they're doing with user data. Just think about the parsing bugs that I mentioned before. And also, if you're using blacklists, just keep them updated. Just maybe look regularly at the Slackers forum as well. So, and last thing, yeah, even if your cross-site scripting filter passes the cheat sheet from Elsnag, this really does not mean that you say from XSS, the guys from the Horde team and other applications as well thought about this too, and this is unfortunately not true. So, any questions now? Yeah, they will be available there. Definitely. So just to mention, I put on the speaker notes also a lot of links there, just in case you want to dig further into this one or other issues, just to keep an eye on that.